So basically I'm going to come on record about talking to the class. Welcome. This is Math 209, Calculus 2 for biology majors, called Elements of Calculus and Statistics. So we will be doing some calculus and its applications, especially ones of interest to biology majors, also probability and statistics in this class. My name is Jhevon Smith, as you can see there. You can call me Jhevon, it's fine. That is my email, very important. I'm going to be asking you to email me shortly. Office hours by appointment. I'm on campus every day, so I'll be flexible. And you just email me and let me know when you want to meet, and we'll try to set something up. This is my website, also very important. I'll be posting important information there from time to time. Things like reviews for exams, solutions to exams and quizzes. I'll post the syllabus there pretty soon, and just any information that you need to know. The text we'll be using is Mathematical Methods for Life Sciences. It's written by Edward Grossman, which was a professor here, now retired. We print the textbook in-house, so to get one, you just go to the math department. It's like a $5 or something like that, something meaning, right? Just to cover copying costs. So you can go to the math department. I'm not sure if they have the text now. It's kind of hectic now with registration. The line's down the hall, but as soon as that sort of clears up, maybe by early next week or late this week, you should be able to get the text. The location of the math department is here. It's in this building. It's on the 8th floor, 8133. That's the math department website. It's pretty important for you to have that. And this is this class's website. So they'll post information about the class at that website, and I'll be sending you there because they have things like past finals that you can practice from. Because we'll be taking a department final, which means I don't write your final. Someone in the math department writes your final, or maybe several of the seniors professors write your final. And they posted past finals online, so you can see an example of what you'd be expected to know. So it's good to have that website. As far as calculators are concerned, non-graphing scientific calculators are permitted. You need to make sure you have the square root function and the exponential keys, like y to the x, e to the x, ln, things like that. Make sure your calculator can do factorials. We discourage using graphing calculators because we'll be asking you to graph things, and we don't want you to have the calculator do the work for you. So yeah, make sure you have a scientific calculator. Here's the grading scheme. It's pretty much the same as always, so you can look at that. And right, so the final is worth 40%, and in-class work it will be worth 60%. That's math department policy. I have no choice there. And this is the breakdown, as you will see. Quizzes count for 15% of the class. In general, we'll have like one quiz per week you can expect. So a quiz or one test per week. I'll drop the worst two quizzes. Homeworks will be worth 5%. That is written homework. We'll get back to that. Participation, which basically is attendance. You just show up and mark you present and early and get that. Excel homework is another 5%. So homework in total is 10% of the class, both written and Excel, and that we'll talk about later as well. In-class tests was worth 30% of your grade. Basically, I'm giving 4 exams, and I'll count the best 3, so I'll drop the worst exam. And the finals is 40%. It's cumulative. It'll cover everything. In general, my exams are not cumulative. They'll just cover different sections. Moving on, no extra credit, don't even ask. No makeups, don't even ask. Attendance, I'll take at the beginning of every class, like I just did. It's my way of getting to know your names. So it's one of the ways I'll get to know your names. And okay, if you're going to be late or absent, email me within 1 day of the particular later absence with the excuse, and all that. Proof is required where necessary. Okay, let's see what else is there. Expectations, work ethic. Don't slack off. Work like your life depends on this class. Okay, homework. I'll be assigning homework all the time. Pretty much every time we finish a topic, I'll give you homework on that topic. The list of homework problems are already determined. There's a list of homework problems here. So basically, once I finish a topic, assume that the homework for that topic is due by the next class, right? And try to get them done promptly because I'll be going over homework problems and any questions you guys might have. But the list of homework problems will be right there. And you can see like the location of the tests will also are also defined. So I said, oh, test 1 will cover everything in this group. Test 2 will cover everything in that group. 3 will cover everything in that group, and so on and so forth. And the date of your final is also already determined, so that's when it all ends. Location to be announced, but we know the date and time already. Let's see, what else is there? All right, so here we have the written homework. I require that you hand it in with certain stipulations. I've listed them here, and I'll take off points if you don't obey the stipulations. Okay, more expectations. Expect you to remember all the math you've ever done. Like 205, you need to remember 205. You need to remember how to differentiate, remember how to integrate various kinds of things. Remember everything, don't forget anything. And I will assume you're experts at all lower level math classes. Just a word of caution, for those of you who took 201 and not 205, that's the Calc 1 for like engineering and science and other science majors. They do not do exponentials and logarithms in that class. So if you're unfamiliar with exponentials and logarithms, you need to work on that on your own because I will be assuming you know about exponentials. Well, so that's guys like e to the x and y equals ln x. Functions like these, how to do calculus with them, how to differentiate them, integrate them. Well, you didn't learn how to integrate this, but you learn how to integrate that. And so dealing with these functions, knowing their graphs, how they behave, that's pretty important. We'll be using these functions all the time. If you did math 201, you wouldn't have seen this. In 205, you use this all the time. I will expect you to be familiar with these functions and their behaviors in all senses. Okay, what else? By the way, I don't know if I need to talk about these homework requirements. Maybe I'll just go over it. Yeah, so when you're handing in written homework, show all your work is very important. Just write down the answers. I'm not going to give you any credit. Make sure it's stapled if it consists of more than one page, and make sure it's properly labeled, right? By properly labeled, I mean it should have your name, the homework number, and the topic number. So for example, let's say you're handing in the first homework, right? I expect you to have the heading, write your name, which is probably not Jhevon Smith, and you'd say this is homework 1, or you can write topic 1, and then below that you'd write section 1.1 to 1.2. And then you do the homework, right? So this should be at the top of your homework, right? Every one you do. And there will be times that I get through several topics and the homework for like 2 topics or 3 topics are due. Staple each topic separately, right? So if you have topic 1, staple all the page for topic 1, staple all the page for topic 2 separately. Even if you're handing them in both at the same time, separate the topics. That will be important to help us keep everything organized. Yeah, and be neat, right? So I can read your writing. All right. Next expectation is for you to repeat the mantra to yourself 10 times a day. So 5 times when you wake up, 5 times when you go to bed, you are going to repeat this mantra to yourself. Very important. The first thing in the mantra says, I must not cancel across sums. Does anyone know what cancel across sums means? Yeah, you know what cancel across sums means? So it's in case, if you have some like, 2x plus 1 divided by 2, and then you're like, you cancel the 2's. No, you cannot cancel the 2's. There's a plus sign separating terms in the numerator. You cannot cancel across sums. There's a plus or minus sign separating things. Can't cancel. It's a completely different thing if this is in brackets. Then you can cancel the 2's because it's multiplication. You can cancel across multiplication and division. You cannot do it across sums. Do not do this. Okay. Another thing, I will not distribute powers across sums. For example, if you see something like and you do that, no, that is not true, right? You can't just, square this and then square that. It doesn't work because there's a plus or minus sign in between it. You can't distribute powers across sums. What is this, by the way? X plus 1 all squared is what?
X squared 2x plus 1.
X squared plus 2x plus 1, right? Because x plus 1 all squared is like x plus 1 times x plus 1. And if you FOIL and multiply out and regroup, that's what you get. Do not assume that powers distribute across sums because they don't. And you will always get the wrong answer. Very usually get the wrong answer. Must not divide by 0. I've seen kids do it. I don't understand it. Just division by 0 doesn't make any sense, right? If you have to divide by 0 to solve something, it means there is actually no solution. Don't be like, 2 over 0. The answer is 0. No. Or the answer is infinity. No, it's not. Division by 0 does not make sense, right? It does not make mathematical sense whatsoever. Don't do it, right? Cannot divide by 0. Never divide by 0. Use brackets appropriately. So let's say, for example, I have this function. Well, I'm not going to ask you to do this, but since you've done Calculus 1, it will be sort of familiar to you. If I ask you to compute that, how would you do it? What would the first part be? X plus h all squared plus x plus h plus 1. Now when you put a minus sign, what are you supposed to do? Bracket or parentheses or whatever you want to call it. Then you put the function here. Right? In general, after a minus sign, if you have several terms, you want to subtract something, you have to put it in brackets. Because that negative sign has to distribute. And a lot of kids would leave the brackets out, and they'll be like, well, I know it's there, I know I'm going to distribute it. But when you're in a test, there's 5 minutes left, you're under pressure, you need to get through that problem quick, you're not going to remember that the brackets were supposed to be there. So get in the habit of using them correctly. Put them there so you remember how to do the algebra correctly. Right? So all those things I mentioned are important. Those are the biggest algebra mistakes I've seen in all my time teaching, and they are responsible for a lot of points being deducted. And it just shows that you really don't know what's going on and you haven't been paying attention in math class for a long time if you do things like these. Do not do them. And just to show you that I'm serious, there's a penalty for doing any one of these things. You will get 0, for everything, right? So once you do any one of these things, I don't care what else you've written, I'm giving you a 0 and moving on. Do not do them. Very serious, very important. Okay. Other offenses that you shouldn't be making. By the way, you should be following me with the thing. You did?
Yeah.
Okay, you got over there?
Yeah.
All right, good. What's that? Don't know, tell me once. What is it? Huh? No guesses? It's an integral. No, it's not a derivative. Pretty much the opposite. Huh? Antiderivative. Yes. I mean, I want you to tell me the answer. So put this on your paper and I say compute it. What's the answer?
Can you du that one and substitute?
No, substitution is not necessary. 1 over x squared. Anti-differentiate.
It's ln x.
Okay, so someone said ln x squared. And that's wrong. First mistake here. Do not assume that 1 over x to the n is ln of x to the n. This is not true in general. Right. The correct way to do this is to rewrite it as x to the negative 2, use the power root, add 1 to the power, divide by the new power. So it's minus 1 over x plus c. That would be the correct answer. 1 over something, when you integrate that, you don't automatically get ln. There's only one specific case where you get ln. The denominator has to be a linear function. That n, the power, has to be 1, right? So you only get ln if you have 1 over x dx. That gives you ln x, right? Or it can be a linear function. So if it looks like y equals mx plus b, you'd also get ln. So it's something like 2x plus 1. This is a linear function. The power of x is 1. This looks like mx plus b. That would also give you ln. In this case, it would give you half ln. Where this half comes from doing the substitution. Right? You say u equals 2x plus 1, blah, 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 and then apply this rule, you get the ln. Right? So in general, this gives you and that is the only kind of function that will give you an ln. If your function does not look like this, exactly like this, for constants a and b, you will not get an ln. This does not look like that because the power is a square. The power is not a square in the general term. Right? So if you do 1 over something and you write ln and the thing is not a linear function, very bad. I'm telling you right now, I'm going to try to catch you with this. I'm going to try to trick you, and I'm going to throw these guys all over the place and try to see if you're going to put it in there. Right? Just full disclosure. I'm going to try to catch you with this all the time. Right? Other mistakes. Eventually we'll be doing probability. If you haven't done probability before, it's okay, but when we get to probability, make sure you understand that a probability will never have a value outside of 0 and 1. Probabilities will give you values between 0 and 1 inclusive. So if you do a problem and you're like, oh, the probability is -1, no, it cannot be -1. Or, oh, the probability is 3, it cannot be 3. It has to be either 0 or 1 or something in between. Do not give me a value outside of that range. Probabilities cannot be outside of that range. When we get to statistics, we're going to talk about something called the correlation coefficient. That one has values between -1 and 1 inclusive. If you give me a number outside that range, very bad. I'll be a little bit more lenient. If you do one of those mistakes, since it comes a little later in the day and it's not as elementary as these ones, I'll just give you 0 for that problem. But you still get a 0. Right? Do not make those mistakes. Very big mistakes. Very serious mistakes. Mess up a whole lot of things. Okay? Okay, so those are some of my pet peeves, but they are responsible for a lot of kids failing math class. So I want to discourage you from making those mistakes. Contact, very important. Contact me by the end of today. Email me at the email address that you have at the front and let me know your name, the class you're in, and its section. So we are in Math 209. I believe it's section CD2. This is the course section. So say, hey, my name is so-so. I'm in your Math 209 class, section CD2. Just send me that email. The reason being, I will be, and send me from an email that you actually check regularly. If you don't check your college email all the time, don't email me from your college email. I'm not going to spam you, but I need to send you important information all the time. I also do an electronic report card system, so I'll be sending you report cards ever so often, like throughout the semester, so you'll constantly sort of know where you stand in the class. So I'll be sending that, among other things. You know, any important announcements or anything like that, I'll put you guys in an email list and I'll send emails to the class. So it's very important that you email me so that I have your info so I can put you in the mailing list, and email me from an email that you check regularly. Okay. Feedback. I encourage feedback. Right? So if something's not working out for you, if you don't understand something, if you'd rather me incorporate something else in the class, you can tell me, whether good or bad. You have to say something positive or negative. It doesn't matter, right? Just, I'm here to teach you, and I want you to learn. So if you think anything can help you learn better, it's good for you to tell me, right? And like I said, positive or negative doesn't matter. You're not going to be downgraded for it. Don't worry about it. And if you ever worried about it, there's still an anonymous feedback feature on my website. I mean, if you're very suspicious, but I promise you I won't. Just make sure it's constructive. So don't just like email me and say, your teaching sucks, right? You can say, your teaching sucks because you do this, you do that. I thought you did this. Probably better if you do it this way, maybe you should do that. Okay, so just make it constructive and that'll be fine. Help, for those of you who need help, free help is available all over campus. There are a bunch of tutoring centers around. The one I most highly recommend is the one in the Marshak building, the 4th floor, room 418S. I tutor there a lot, so you can see me there a lot of the times. And this is the current schedule, all right? And it opens on February 2nd, I believe, so that's next Monday. Listed a lot of online resources as well, so mathhelpforum.com, worldgroundalpha.com. You can find tons of videos on YouTube, Khan Academy, check it out. Google's your friend, So there's help all over the place. And for some of you who are in special programs like SEEK or the accessibility program, they have their own tutoring centers, a lot of them, but this tutoring center is really great because, I'm there, and a couple of the other tutors that are there have actually taught 209 before, so you really have the experts here. So it'd be good if you'd like to go there to get extra help on anything. Class rules in general: eating not allowed. Drinking is okay if you're a person who needs their coffee. That's the afternoon pick-me-up. Academic integrity, the usual policy: don't cheat. I don't like cheaters. Next is academic calendar, because there are a lot of important dates, some more important than others for some of you, depending on what's going on in your life, so I decided to include that. And again, I already mentioned this, but this is the topic list. So this semester we will be covering this list of topics. Do I skip anything? Yeah, the last chapter 15 I might skip, but we'll pretty much cover everything else. Right, so that's our list of topics. As I said before, these are the homework problems, and this is the section, the homework number, and that. This is course learning outcomes. Since we're accredited, I'm required to give this to you at the first day of class, so it's what we expect you to learn by the end of the course, so you can read through that. And on the last page, there is a questionnaire that I would like you to fill out. Anonymously is okay, you don't have to put your name on it, but just fill this out and hand it back to me by the end of class, and that would be good. And then all you have to do, once you finish, just tear it off, because it's the last page. So just give it to me. So that was my quick spiel about sort of the general day-to-day operations we'll be undergoing. Are there any questions, comments? Oh, you didn't get a syllabus. Yes? Oh, you need a syllabus as well. Does anyone else need a syllabus? Do you need a syllabus, or do you have a question? Oh. Okay, question.
Under academic integrity, you say cheating includes submitting homework without properly acknowledging people who assist you. Does that mean like other classmates, or like going to the other resources provided, or that isn't something you need to list, right?
No, well, things like the Excel homework, if you worked on it with someone, you should say it. For homework in general, no, I don't really care. But of course, tests, you can't collaborate with anyone. Tests and quizzes, of course. Any other questions? So I'm guessing most of you here are biology majors. Is anyone not biology? Where are you?
Pre-med. With post-bac.
Okay.
It's almost there.
Yeah. Psychology, like your bachelor, you're doing Bachelor of Science, I guess. Okay. All right. Any other questions, concerns? Time. So this class does have an Excel component to it. I guess if you guys need me to go over Excel stuff, I'd have to like get a laptop and sort of get up to this projector. And we can do some Excel work if needed. Is everyone familiar with Excel? Does anyone not know about Excel? You don't know about Excel? For the Excel homework, I don't remember if I mentioned this, but when you're going through the homework problems and you go through this list, in the textbook, the ones that require Excel, you'll see a little computer at beside the question, and that means they'd like you to do it in Excel. And so when you do that, there are packages that you will need. What you can do is go to the math department website, the 209 website, and there should be a link to the files that you will need. It should say something like math 209 files.zip. It's a zip file or something like that. So some of them will have like, there's code already in the file for you to just manipulate and things like that. So that's also something that I should mention. But in general, I won't really talk about Excel in class unless I have to do some sort of demonstration, in which case you have to tell me ahead of time because I'd have to get a laptop. Other questions? No? Good? Okay. So you guys kind of got me worried with this one. So do you guys remember 205?
Yeah.
Really? Can everyone state the product rule? What does the product rule say? You guys remember that guy? Yeah?
f of x times p prime of x plus f prime of x times g of x.
Well, it's sort of an equation.
Or
What's on this side?
y prime.
Be specific. It's
dydx.
called the product rule.
dydx.
We want to be specific as to what the y looks like. This is saying if you have a product of functions, f times g,
Yeah.
right? Then, as he said, you get f prime times g plus f times g prime, right? So, for example, you have y equals x times 3x plus 1 to the 15th power. Of course, you're not going to want to expand to the 15th power, But if I ask you to find y prime, how would you do it? Well, in this case, this time you'll need the product rule, because you have two functions being multiplied here. This one is f, that one you can call g. So basically you differentiate one at a time. Differentiate this, leave that one. What's the derivative of x?
1.
Plus, now you leave the first one and you differentiate the second one. How would I differentiate this guy?
Chain.
Chain rule. What did that give me?
15 times 3x plus 1 to the 14th power times g of x, which is 3x plus 1, or 3, so.
Right, which is the derivative of the inside, and that's given by the chain rule. So you would have something like 3x plus 1 to the 15 plus
15.
3 times 15. So what if I x to the 3x plus 1, 14. And it just might be the case that we might need to simplify a little bit. So in which case, how would I simplify this if I wanted to?
You can bring
Pull out the common factor, right? Simplifying basically means factor. Right, so what do I pull out front?
pull out from the back, 14th from the front.
I pull out the lowest power, right? If you want to factor out a common term, you always factor out the lowest power. 15 and 14 are the powers, you factor out the lowest one. So what would be left over? 3x plus 1. Because there were 15 of them, I took out 14, so there's one left, one factor left, plus
45.
45x. Brackets are important. Don't forget them. So here you'd have 3x plus 1 to the 14. Here you'd have 3x plus 45x. Right. So this would be the derivative, right? This is called the product rule. And here we sort of used what we call the chain rule. So who can actually remind me what the chain rule says in general? In a similar fashion to that. What does the chain rule say? What's the equation?
Is it, f prime x?
What kind of function? What does it have to look like for you to know you have to use the chain?
F of g of x.
F of g of x. F of g of x. This means you have a composite function. You use the chain rule when you have composite functions. You have like a function plugged inside another function. You use the chain rule. And what does that actually become?
F prime of x.
F prime of g of x, you
G of
leave
x.
the inside alone, times
G
the
prime.
derivative of the inside function. Right? So, example is sort of like what we did over here. Let's say I had 2x squared plus 3 to the 27. And I ask you to find the derivative. Right? So here, you have a composite function. It's sort of like you have x to the 27, except it's not just x anymore. There's a whole function replacing x. Whenever that happens, it's called a composite function. You have this form, and what you do is you do the chain rule. So you differentiate the outside function, which is here, in this case, is the 27th power. So how do we do that?
27.
Bring the 27 down. You apply the
26.
power rule. So it's 27, 2x squared plus 3 to the 26 times, now you different
4x.
Here it is, 4x, correct. And you can simplify that if you want, 4 times 27, blah, blah, blah. Which, by the way, here, again, going backwards, we use what we call the power rule, which is the most basic differentiation rule. It's probably the first one you learned. Derivative of x to the n is what?
N minus 1.
X.
N minus 1.
Right, which is the rule that I've been applying all along. If you've noticed, right, I keep bringing the power down. If it looks like a function, a variable to a constant power, this is how you do the derivative. What about something like the quotient rule? What kind of function does that help me to differentiate?
Fraction.
F divided by g, and what's the formula?
F prime times G minus S
What?
G. F prime times G minus F G prime times G prime over G squared.
That's correct. The bottom times the derivative of top minus the top times the derivative of the bottom over the bottom squared. That is called the quotient rule, and you use it whenever you have a division of functions. So, for example, just trying to jog your memory. I know you're all experts at this already, but just trying to make sure. If we had something like 2x plus 9. How would I do that?
Two.
Times 3x plus 2.
Right, so this here is like the f, this here is like the g. So you have the derivative of f, which is 2 times the g. Right, this is like your f prime, this is your g, minus
2x plus 1
times 3. Again, after a minus sign, I have to put the function in brackets, or parentheses, or whatever. Okay, over what?
3x plus 2.
And of course, you'd be expected to simplify this, so we'd expand the brackets, distribute. So, right, this is a minus because this minus sign will hit these two. Right? So here I get 6x minus 6x, and I get 4 minus 3. That just gives me 1. And that would be the answer. Right? Because I see a division of functions, I know I use the quotient rule. If I see a product of functions, I use the product rule. If I see one function plugged into another function, I use the chain rule. If something just looks like x to a constant power, I use the power rule, right? These things we should all remember. Let's get more specific. What if I asked you, what is the derivative of e to the x?
Yeah.
X. What if I ask you, what is the derivative of e to the u, where u is some function?
U.
Think of u as a function of x. E to the u.
Oh, you have to derive that.
You're right, u prime e to the u. So, for example, if I said y was e to the x squared, and I asked you to find y prime, what's the answer?
2e. 2x.
2x e to the x squared. That would be the answer. You differentiate the power, and you put it in front of the original function. That's how you differentiate e's. And this applies because of the chain rule, right? You think of this as the inside function, right? It's plugged into e to the x, right? It's not just an x anymore, it's an entire function. You have to apply the chain rule, which says you differentiate by the inside. You multiply by the derivative of the inside. What's that?
1 over x.
1 over x. What's that?
1 over x. U prime.
1 over u times u prime, right? This is u prime over u. So, for example, y was equal to ln of 3x squared plus 4. And I ask you, what is y prime? What is y prime?
6x over 3x squared plus 4.
Okay. It's all coming back, right? If I say, what is ln of e to the x?
So e over x.
It's x. What is e to the ln of x?
Oh,
Also x. The exponential and the logarithm are inverse functions. You plug one into the other, you just get the original input. Right? Okay. So, what if I ask you to solve the equation? Something like e to the x equals 5. What is x? How do you get ln 5?
L on both sides.
You plug both sides into the ln, right? In this case, ln and e cancel, so this you mean x must be ln 5. Or what if I ask you something like ln 2x plus 1 equals 7. Solve for x.
E.
What do I do with e?
You take e to both sides?
E to both sides, right? I want to get rid of that ln so I can isolate the x.
So it'll be 2x plus 1 e to 7.
So this, they cancel because of that rule. Over here I get 2x plus 1. Over here I have e to the 7th power, and now algebra, right?
Yes.
X would be e to the 7 minus 1 all over 2. So all this stuff I expect you to remember. So being able to simplify things with e's and ln's in it, being able to solve equations with e's and ln's, being able to integrate and differentiate things with e's and ln's. What's that?
Can you break it up and do ln x times 1 over x? And then solve from there?
So you want?
Yeah, so now you
Then
can
what would you do?
You can do 1 over x times
So can you take the integral of both because it's a...
ln. Yeah.
No. This is a very important rule.
Or do you substitute that?
Yes. Number 2. Do not make that mistake either. If you have the, remember just as how with derivatives you had the product rule? If you have multiply two functions, you can't just differentiate each function and stick them together. It doesn't work. It's not true. Same is true for integrals. If I have a product and I'm integrating, I can't just integrate this, integrate that, and then stick them together. It won't work. You guys don't know how to integrate ln x anyway. That wasn't taught until, if you knew that, you knew from external knowledge, but that's usually taught at a later date because you need another integration technique. But yeah, if there's a product or a division, you can't just integrate each part and stick them together. It doesn't work. There's a whole rule to go through, right? But this can be done with what you know so far. How would you do that? I mean, what are the integration rules that we know so far?
Can you solve?
We know how to integrate things like x to the n, right?
Yeah, so it could be x to negative 1.
Huh?
Can we integrate like,
What's this rule?
oh, n plus 1.
X to the n plus 1
and then n plus over n plus 1.
over n plus 1 plus c, right? So an example would be if I actually find the antiderivative of x cubed, that's just x to the 4th over 4 plus c, right? So if I have x to the minus 1, let's look at that one, what would happen?
1 over negative, well,
It's x plus
I
one,
was-
x minus one.
the final one, because it would be.
It'd be 1.
The negative 1 would go to the front, right? And then it would be minus 1, or plus 1, which is this.
Yeah.
Hmm?
Angle one, just one.
Yeah.
Zero.
Natural log x.
It'd be,
This is ln x. Why could I not apply this rule?
because it'd be not defined.
Hmm?
It'd be undefined.
Undefined. Why? If n is
Zero.
minus 1, the bottom is 0. Never divide by 0, right? So you cannot apply this rule. This rule does not apply to this guy. To integrate this guy, 1 over x, this gives you the natural log with the x in absolute values. Right? So that's 2 rules that we remember. What about another rule? E to the kx dx.
Oh, yeah.
So an example would be something like the antiderivative of e to the 3x dx, for example. What would that be? What's the general rule here? K is a constant,
Bring it out.
a non-zero constant.
Can you bring it outside? No. There's a rule to that.
There's no chain rule for integrals.
But there's a different rule to this one. For logs.
1 over k.
Oh yeah, that's right.
E.
1 over
1 over k e to the kx plus c. So something like this would be a third e to the 3x plus c. Okay. How would you have figured that out? Remember that rule. How would you get to that? Because I'm assuming that you know that the derivative of e to the x is just e to the x.
Yeah.
The antiderivative, right? So why when I put a k here I get 1 over k? What did we do? So you learned all these basic rules. I think in 205, these are all the basic rules you know. But then you learned one integration technique. You only learned one. All together now?
Use substitution.
Substitution, right? There's something called substitution, which you have to remember. It's going to be very important. So basically how this works is if something doesn't fit exactly to one of these rules, you can use substitution to sort of make it look like one of these rules. In this particular case, this is worth memorizing in general, but let's say you forgot for a split second and you needed to remind yourself. You have the integral of e to the 3x dx. And you're like, I don't really know how to do that. I know the integral of e to the x, right? This 3 is messing things up. It's not fitting the form that I need. What you need is for this to just be a single variable. That constant is a nuisance. So what do? You make it a single variable, right? Let's just replace that with a single variable. U equals 3x. Then we'd have to find du,
3.
which means you differentiate both sides, which means here you'd be able to solve for your dx.
Oh, yeah.
So then this integral would become what? Well, you'd have e to the u because you replace that 3x with u. The dx now becomes 1/3 du. This 1/3 is just a constant factor. There's a rule that says we can factor out constants. And now what do you notice about this guy? It looks exactly like a rule I know how to apply, so I just apply it. This antiderivative is just e to the u plus c.
Plug it back in.
And now your u, you have to plug it back in. U was 3x, so you come back and you're like, you know. But for a simple function like this, you should just remember that that's, you know, we don't have time to do this for functions like this. However, for functions like this, it does not look like any one of the rules. It's not x to the n. It's not 1 over x because it's attached to some other function, and it doesn't have e's in it. So it doesn't fit exactly with one of those rules. However, the only technique we have, so if it doesn't fit one of the rules, the only thing you can try to do is substitution. So in this case, the question is, what do you substitute?
ln.
ln.
ln. Why would you substitute ln? Why couldn't we substitute 1 over x?
Because the derivative for ln x is in the equation.
We know that.
Right. So substitution, there are two goals. One, you want to substitute something so it looks like a general rule that you already have. In order for this to work, the second thing you need is for the derivative of whatever you make u should be a factor somewhere else in the integral. So the derivative of ln is actually just 1 over x dx. And we have the 1 over x dx, right? So you sort of need that guy to be a factor. And so what happens is this integral just becomes ln x I replace with u. And then this 1 over x dx I can just replace with du. And now it looks like one of my rules. What rule is that? Do I need? Just the power, right? The first power. N equals 1. So you add 1 to the power, divide by the new power, plus c. At the end of the day, you replace u with what it's supposed to be. And we have the answer. So there are some basic rules that you need to know for integrals, and if you see anything that looks like anything else, try to make substitution work. It's the only technique we're going to ask you about in this course, really. The more advanced integration techniques is not in are not in our syllabus. So you guys got it, right? You're all experts at 205? No? Because you know we need A's, right? We need A's. Okay? You're going to get an A? Yes, good. That's the only answer to that question. We all want A's, we need to be experts. We need to be experts at all previous math classes. And so, to that end, to make sure you're not just slacking off, because we can't have that if we're going to have A's, I have a gift for you today. We have a quiz. Don't worry, it's stuff you know already. It's all 205. So I guess if I wanted, I could make this worth double any other quiz, right? It's easy stuff. We all remember this. Okay. All right, so close your books and do this quiz. And I guess you can turn off the camera.